Okay, so what I want to look at here are just different types of questions that you could be asked when you're working with Pythagoras' theorem. So these are kind of common type of questions. So let's have a look. So find the length of the hypotenuse in each of the following right angle triangles. So we'll take this first one. So this one here is the hypotenuse, and it's opposite the right angle, which is here, which is indicated by this like red quarter of a square. So if we remember, Pythagoras' theorem is a squared, which is the hypotenuse, is equal to, in this case, it's going to be 4 squared plus 3 squared. So let's work that out. So 4 squared, so 4 squared just means 4 by 4 is equal to 16. So 16 plus 3 3s are 9, and 16 plus 9, so 16 plus 9 is equal to 25. So what we're saying here is that a squared is equal to 25. Now what we want to do is we want to get rid of this square. So if you take, in order to get rid of this, you get the square root of it, and that will get rid of the power of 2. And if you square this side, you have to square this side. So then this will just be a is equal to the square root of 25, which is 5. So the answer to this first one then, a is equal to 5. So this squared plus this squared is equal to this squared. So then the next one, so again this is the hypotenuse, this is the right angle opposite the hypotenuse. So again, so what we're saying here, so this is the first part, so that's that first question. So we look at the second one now. So what we're saying is that b squared is equal to 5 squared plus 12 squared. So again, 5 5s are 25 plus 12 by 12, let's get a calculator, it's 144, it's 144, and then 25 plus 144 plus 25, 144 plus 144 plus 25 is equal to 313. So what we're saying here is that b squared is equal to 313. So then we get the square root of this, and we get the square root of this. So b is equal to the square root of that number. So this should be, just work this one out, it's not quite right. So this should be equal to, it's equal to the square root of 169, and the square root of 169 then is equal to 13. So b is equal to 13. So b in this case is equal to 13. Then we have a look at this one. So again, we have c squared is going to be equal to 9 squared plus 12 squared. So 9 by 9, 9 squared is 81. 81 plus 12 squared is 144. And if we add these two together, 144 plus 81 is equal to 225. Sorry, 225. So that's equal to 200. So what we're saying then is that c squared is equal to 225. We get the square of this and the square of this. That cancels out with the 2. So c is equal to the square root of 225, which is equal to 15. So this is equal to 15. So C in this case then is equal to 15. So C is equal to 15. So then if we have a look at these, so again, it's the same. So give your answer correct to one decimal place. So again, this squared is going to be equal to this squared plus this squared. So what will that look like? So a squared is going to be equal to 6.5 squared plus 9 squared. And 6.5 squared is equal to 42.25. 42.25 plus 9 squared. So 9 squared is equal to 81 plus 81. So 42.15. So 42.15 plus 81. That's equal to 123.15. So it's equal to 123.15. And then, so that's a squared is equal to 123.15. So we get the square root of this and we get the square root of this. And the square root of that is equal to 11.09. So a then is equal to 11.09. And then it asks us to correct to one decimal place. So a is going to be equal to 11. Okay, and so the rest of them are just very similar to that as well. So they're just the very common examples of questions that you could be asked to do using Pythagoras' theorem. Okay, thank you for listening.